Hi, this tutorial looks at the pie graph spatialization component of Dhour. This tool is useful for a quick read of relative quantities. Its inputs require a list of values, with each element of the list representing a slice of the pie. So let's start fresh. And we'll begin with some of our work already done for us. Here you can see we have a set of colorized data hours that have already been binned into 22 subintervals according to dry bulb temperature. So now we're ready to use our pie graph component. We'll pull this down, and we can see that its inputs require a set of values, colors, the optional location, and radii. So let's begin by getting the colors from the d-hours. We'll use the primitive getColor component, and then because this getColor is actually pulling in a list of colors for each subinterval, we're going to average those colors so that we have a single color per interval. These frequencies that come from the binning component get pulled in as our values. Here, we're seeing a single shade because the pie graph calls for lists and we're giving it data trees. So by right-clicking these outputs and flattening them, we'll give it the correct inputs. So to simplify our viewing of it, I'm just going to pull down mesh and curves so that we can view our outputs more individually. And so now we see that the curves are the dividing boundaries between our colored meshes, and the colors that are output pertain to the values of that data set. The colors correlate to the relative values of the graph for a more intuitive read, creating a specified spectrum instead of a random assortment of hues. So if you'd like to customize your pie graph further, we can adjust its input location by setting one plane, or we can adjust the radii by using a simple panel input to specify its internal radius to its external radius. And there you have it. That wraps up our pie graph.